We are going to start now lecture 12 of chapter 10, class 11th mathematics, straight lines. In our previous lecture, we have talked about the homogeneous equation of degree 2. Now we are going to talk about the general equation of degree 2. So it is of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this equation, this can represent a straight line, a pair of straight line, circle, parabola, ellipse or an hyperbola. So it depends upon the conditions on these coefficients a, h, b, g, f and c, and depending upon these coefficients it can represent any of these curves. So we are saying that these are the coefficients, these are being mentioned over here. So our result is the necessary and sufficient condition for this equation to represent a pair of straight lines is that this determinant means this value we are talking about, this value should be equal to 0. So to prove this result, we are considering the first case, that this condition, it is necessary condition, that is we are assuming that this equation, it represents the pair of straight lines. So we have to prove that this condition should be satisfied. So suppose the first condition we are assuming over here is that these two lines, the two lines we are talking about, that these equation, these are representing, they are not parallel to each other. We are assuming this thing, this equation we are talking about of second degree, we are assuming that it is not representing the straight lines which are parallel to each other. So if the two lines, they are not parallel to each other, then they will intersect at some point. And suppose the point of intersection that we have, it is x comma y, or it is x1 comma y1. Now if we shift the origin so that this point x1 y1 lies at the origin, we shift the origin to the point x1 y1. So the transformation we are going to use over here, it is x is equal to x plus x1, y is equal to y plus y1, and we substitute these values in this given equation and we obtain the answer in this form. In this equation we are talking about, this is the new transformed equation with the in the new coordinate system, where the origin is being shifted to the point x1 y1, and when the origin is shifted to this point, it means their point of intersection is now 0 0, and we know that the pair of equations that intersect at point 0 0, they are basically, we are talking about the homogeneous system, and the new equations we will obtain, they will be of the form ax plus b y, ax square plus by square plus 2hx into y is equal to 0, because this is the system of equation which intersect at the point 0 comma 0. So what we can see from this is, we are talking about the case, if the equation is of this form, it means the coefficient of x, coefficient of y and constant term, they are equal to 0. We are talking about this equation. If this equation is to be homogeneous, then we are saying that the coefficient of x, coefficient of y and constant term, they should be equal to 0. So if we equate these values equal to 0, we are getting ax1 plus hy1 plus g is equal to 0. Second, we are getting hx1 plus by1 plus f is equal to 0. And the third condition we are getting, it is ax1 square plus 2hx1 y1 plus by1 square plus 2gx1 plus 2fy1 plus c is equal to 0. So these are the three conditions we are obtaining by substituting the coefficient of x, y and constant term equal to 0. We are talking about coefficient of these terms, we are substituting them equal to 0, and from these conditions we will obtain the final answer in this form. We are saying we have 3 equations and 3 unknowns, and to eliminate these equations we have the condition that this determinant should be equal to 0, only then the solution will have some solution will exist, or it will have some solution. So we are saying this is the required condition, that this determinant should be equal to 0, only then this equation, general equation of second degree, it will represent a straight line. Now we come to the case when the two lines they are parallel to each other. We have considered the case that two lines they are not parallel to each other. Then we have considered that they are intersecting at the point x1 y1. Now we are talking about the case when the two lines they are parallel to each other. So the condition we have, it is a b minus h square should be equal to 0, and the method that we are using in the previous case, it cannot be used because there is no point of intersection over there. So we are saying this is the equation given to us, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now suppose we have two lines and the equations of lines they are given by lx plus my plus n is equal to 0, and l dash x plus m dash y plus n dash is equal to 0. So we have equated both these values. We have equated these two equations over here. We have equated these two equations over here. And if we compare the coefficient of both these equations, compare the coefficient means we are talking about x square, we will have the term over here, it is l into l dash. So we are saying l into l dash is equal to a. Then we will have xy, the terms of xy over here, it is l into m dash plus m into l dash. We are saying this value should be equal to 2h, and we have obtained these equations by comparing the coefficients of x square, y square, xy, x, y and constant term. We have obtained these equations, and if we eliminate the value of l, m, n, l dash, m dash, n dash, these equation will come in this form, and we are saying that this determinant that we are talking over there, again we are getting the same condition that this determinant of a, h, g, h, b, f and g, f, c, they should be equal to 0. So we are saying that the condition, it is same in this case also. So we are saying that the final condition that we have obtained, that if any general equation of degree 2 is given, then this will represent a pair of straight lines. The condition we have is this delta, this determinant should be equal to 0. Now next we are going to prove that this condition is sufficient. So to prove that this condition is sufficient means we are talking about, now we are assuming that this determinant, this is equal to 0, and we have to prove that this equation of second degree, it will represent pair of straight lines. So from the condition that this determinant is 0, what we obtain is that if we have three lines ax plus hy plus g is equal to 0, this is from the first row over here. Next is hx plus by plus f is equal to 0, this is second equation of line, and third equation of line we are writing it is gx plus fy plus c is equal to 0. We are talking about these three equations. As this determinant is equal to 0, so we are saying that these three equations or these three lines, they are concurrent, that is they pass through a point, and suppose that point we have it is x1 y1, and if all these three lines they pass through this point, it means it will satisfy these relations. So we get a x1 plus h y1 plus g is equal to 0, h x1 b y1 plus f is 0, g x1 plus f y1 plus c is equal to 0. We have obtained these three equations, and now we are saying that shifting the origin at the point x1 y1, we are saying the point of concurrency of these three lines, it is x1 y1. Now if we shift the origin to this point, we are talking about this equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. When we shift the origin to this point, this equation is transformed into this form. We are saying we are shifting the origin to the point x1 y1, and the new equation we obtain in this form. And on solving these terms, you will obtain the equation in the form ax square plus 2hxy plus by square is equal to 0, and this is a homogeneous equation of second degree, and we know that this represents a pair of straight lines passing through the point 0 0, where we have shifted the origin to the point x1 y1. Now these 2 points, they coincide. So we have proved that if this condition is given, then this equation will represent a pair of straight lines. Now in certain problems, we have to use the result in this way. We are saying, suppose the two equations we have, one equation is y is equal to m1x plus c1, second is y is equal to m2x plus c2. Now these are not passing through the origin. We are talking about the general equation of straight lines. Now if we compare the joint equation of these two lines with the given homogeneous equation of degree 2, we will obtain certain results. We are saying first is m1 plus m2 is equal to minus 2h by b, m1 into m2 is equal to a by b, m1 c2 plus m2 c1 is 2g by b, then c1 plus c2 is equal to minus 2f by b, and last is c1 into c2 is equal to c by b. So these are the relations that we will obtain if you substitute, if you calculate the joint equation of these two lines and compare it with the general equation of second degree. So these results, these will be used in solving certain problems. The next result we have is the angle between the lines represented by the general equation of degree 2. It is given by theta is tan inverse of this value. So suppose we are saying the two lines that we have, one is y is equal to m1x plus c and second is y is equal to m2x plus c. Now by comparing the coefficients, what we have obtained, we are saying the joint equation we have, it is y minus m1x minus c into y minus m2x minus c. When we multiply these values and compare it with the given equation of degree 2, we will obtain that m1 plus m2 is equal to minus 2h by b, and m1 into m2 is equal to a by b, and the angle between two lines y is equal to m1x plus c and y is equal to m2x plus c tan theta, that is given by mod of m1 minus m2 over 1 minus m1, 1 plus m1 m2. If we substitute these values over here, we will obtain that the angle, the required value of angle that we will have, that is theta is equal to tan inverse 2 square root of h square minus ab divided by mod of a plus b. So this is the required value of theta that we have, that is the angle between these two lines. So we are saying the angle between the lines represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, and the angle represented by the homogeneous equation ax square plus 2hxy plus by square is equal to 0, both the angle they are same. And similarly, as in the case of homogeneous equation, we have obtained that the two lines represented by this joint equation, they are perpendicular if a plus b is equal to 0 and parallel if and only if h square is equal to ab. So similar kind of conditions we have for the general equation of degree 2. Next is the lines represented by the general equation of degree 2 will be coincident. These two lines, these will be coincident if these three conditions, these are satisfied. We have to prove this result. So suppose we are saying that the two equations corresponding to this joint equation, they are the lines we have, it is Lx plus My plus n is equal to 0, and second is L dash x plus m dash y plus n dash is equal to 0. So if we try to find the joint equation, we get it is Lx plus My plus n into L dash x plus m dash y plus n dash, this is equal to 0. This is the joint equation we will have, and both these are representing the same joint equations. So when we compare the coefficients over here, we will obtain L into L dash is equal to A, m into m dash is equal to B, n into n dash is equal to C. Similarly, we will have L into m dash plus L dash into m is equal to 2h. So these are the conditions that we are obtaining by comparing these values. Now it is being given that we are talking about the case that the two lines, they are coincident. So if these two lines, they are coincident, then from this condition we will have L over L dash, that is equal to m over m dash, that is equal to n over n dash. Now from these ratios, if we consider the first two, we will have L m dash minus m L dash is equal to 0. From the next two, we will have m n dash minus m dash n is equal to 0. And from the third, we will have L n dash minus L dash n is equal to 0. These are the three conditions we will have. And by combining these results, we will have L m dash plus L dash m square minus 4L L dash m m dash square root, that is equal to 0. Similarly, we will have this second result, and similarly we will have this third result. From these conditions we can obtain this. And now by using these values, we have these values over there. So by substituting these values, we will obtain the final conditions, the final three conditions in the form that h square minus ab should be 0, f square minus bc should be 0, and g square minus ac should be equal to 0. So we are saying that the lines represented by the homogeneous equation of degree 2, the general homogeneous equation of degree 2, will be coincident if these three conditions, these are satisfied. These are the conditions that we will have. So based upon this, we are going to solve certain problems. So the first question we have is, for what value of lambda the equation, this equation is given, it is 12x square minus 10xy plus 2y square plus 11x minus 5y plus lambda is equal to 0, represent a pair of straight lines. First of all, we have to calculate the condition, and the condition we know is the determinant we are talking about, that should be equal to 0. The value of the determinant we know, it is ABC plus 2FGH minus AF square minus BG square minus CH square should be 0. So if we substitute the values from this equation, we will obtain the result in the form, this calculation, these are shown over here. When you substitute these values in this result, you will obtain the result in this form, and on solving this you will get lambda is equal to 2, and second we are saying h square minus ab, that is equal to 1 is greater than 0. So we are saying the given equation represent a pair of straight lines if lambda is equal to 2. So this is the required condition in this case. Now next we have to find the equation and the angle between them. So to find the equation of the two lines, we are going to write the given equation, the given second degree equation we are talking about. It is written in the form, we are saying it is 12x square minus 10xy plus 2y square. We can split or factor these terms as 2 into 3x minus y into 2x minus y. Now, if we consider the equations in the form, we are writing it is 3x minus y plus L and second is 2x minus y plus m. We take the product of these two. On multiplying these terms, you will get it is 12x square minus 10xy plus 2y square plus 2 into 2l plus 3m into x plus 2 into minus l minus m into y plus 2lm, and this equation should be equal to this value. So from this we will obtain that 2l plus 3m, we are talking about this portion over here, 2l plus 3m, that should be coefficient of x over here, we are getting it is 11, and minus 2l minus m, that should be equal to minus 5. So we are writing 2l plus 3m, that is equal to 11 by 2. L plus m is equal to 5 by 2 and L into m is equal to 1. And on solving these values, on solving these three equations, we obtain L is equal to 2, we obtain m is equal to 1 by 2. So by substituting these values over here, we will get the two equations in the form, it is 3x minus y plus 2 into 4x minus 2y plus 1. We are saying this should be equal to 0. So we are saying that this joint equation, it is representing two straight lines. One is having the equation 3x minus y plus 2 is equal to 0, and second is having the equation 4x minus 2y plus 1 is equal to 0. So these are the two equations, two separate equations corresponding to this joint line. Another method to solve this is, we are saying this is the equation given to us. We can rearrange the term and write the values in this way. We can rearrange the terms and we can write it as a quadratic equation in x square. We are writing it is 12x square minus 10y plus 11x plus 2y square minus 5y plus 2 should be equal to 0. This is a quadratic equation in x. If you calculate the roots of this equation, you will get the value of x in this form. And on solving these two values, we will obtain the two equations. One is 3x minus y plus 2 is equal to 0, and second is 4x minus 2y plus 1 is equal to 0. So these are the two equations that we have. So it is up to you that how you want to calculate these equations. The last thing we have to calculate over here, it is the angle between these two lines. So we are saying the value, the formula for angle we have, it is given by theta is equal to tan inverse of 2 square root h square minus ab divided by mod of a plus b. So the answer we obtain over here on solving this value, substituting these values, the answer we obtain is that the value of angle we have over here, it is tan inverse 1 by 7. This is the angle between these two lines. Next is prove that the equations given by these joint equation represent a pair of parallel straight lines. We have to prove that these are pair of parallel straight lines, and further we have to find the perpendicular distance between them. So when we are talking about this first equation, we write it in the form 8x square plus 2x into 4y plus 13 plus 2y square plus 13y plus 15 is equal to 0. So we can see from here, this is the coefficient, this is the x square part. Next, this is coefficient of x, and this is the constant term that we have. So we are saying this equation we are talking about, this whole equation we are talking about, this is a quadratic equation in x. So when we solve these values, we will obtain the value of x in this form. When we solve these values, we obtain the value of x in this form, that x is equal to minus of 4y plus 13 plus minus 7 by 8. So these are basically two equations. One is x is equal to minus 4y plus 13 plus 7 by 8, and second is x is equal to minus 4y minus 13 minus 7 by 8. And on solving these two equations, we obtain that we are getting two values. One value we are getting, it is 4x plus 2y plus 3 is equal to 0, and second we are getting it is 2x plus y plus 5 is equal to 0. So clearly both these lines, these are parallel to each other, and this is the first part we have to prove, that both these lines, these are parallel to each other. You can see by calculating the slope of both these lines, and the slope of both these lines, these are equal. So it means both these lines, these are parallel to each other. Next we have to calculate the perpendicular distance between them, and we know the formula to calculate the perpendicular distance between two lines. We have one line, it is x 2x plus y plus 3 by 2 is equal to 0, and second equation we have, it is 2x plus y plus 5 is equal to 0. The perpendicular distance between them is given by 5 minus 3 by 2 divided by square root of 2 square plus 1 square. So the answer we obtain, it is 7 by 2 root 5. So this is the value of the perpendicular distance between two parallel lines represented by this joint equation.